So we're going to finish off this afternoon by just having a fairly brief panel discussion. And I've got 4 questions that I kind of want to ask as a panel, if I may, and perhaps even the audience, because I'm sure you guys, particularly the modelers amongst you, might have opinions on some of the questions I'm going to ask. But before I ask the first question, can I just ask the panel again, just to maybe go from this end and just remind us all who you are and what your kind of main research interest is.
So, hello everyone, my name's Simon Fowler. I'm a lecturer in Programming Language Foundations at the University of Glasgow. My research centres around type systems and domain-specific languages.
Hello, my name is Peer-Olaf Siebers. I'm from Nottingham University, computer science, and my main interest is in methodological advances in building nature-based models.
Hi everyone, I'm Hongge. I'm from local. I'm in the engineering department in the machine learning group. My work relevant to this event is about probabilistic programming, but I also work on other machine learning problems like neural networks.
I'm Justin Lessler. I'm at UNC Chapel Hill, and my work focuses on infectious disease dynamics with a pretty strong focus on direct operational support of public health agencies.
And I am Guillaume Baudart, so I'm an INRIA researcher in Paris, and I'm working on probabilistic programming and language design.
Fantastic, thanks very much. Okay. So my first question, I'm not quite sure whether you guys can see on the monitor at the back, but given that this day has been about sort of discussing techniques in probabilistic programming and thinking about it in the context of kind of epidemiological models, what kind of approaches can we take to promote engagement from the epidemic modelling community and statistical developers in contributing to PPL projects? Maybe go from the left-hand side.
Actually, I don't know, because you seem pretty interested here, so
Yeah.
I feel like we already have one foot
Sure.
in the right direction. And I guess we could work more on accessibility of the language. So make things easier for you to work with. And I'm thinking in particular on the fact that some of you want to hack directly on the inference engine and make like clear APIs or clear libraries to do that would be must.
Okay.
I mean, I think a lot of it has to do, right, like with meeting people where they're at. I think for the larger modeling community, you know, if you don't, like, it's going to be hard to get good engagement if you don't have some pathway in from R to maybe, you know, and maybe Python. Mm-hmm. And you know, because people are just used to working that, they're dealing with all their data. You gotta remember, they're dealing, like, the programming of the model part of it is such a small part of what, like, a practicing epidemiologist who works with models does. So much of it has to do with ingesting and understanding data and the analysis and presentation of the output and stuff like that. And if you're asking, there has to be a really strong value proposition if you're going to ask them to step out of the world where they do that, all that stuff, to do the modeling part. And you know, I think that's one of the reasons Stan is so successful, is because the R-Stan interface, it's not just that Stan's a pretty nice clean language stuff and works well. It's the R-Stan interface is really clean and effective, and I think that's a large part about why, you know, sure, people are, even if it's maybe not the best sampler for your problem, like, people will go there.
Yeah. Thanks.
2 thoughts. One is very related to the previous remark. I think it is important to make the language very accessible. The syntax and inference algorithm should be as general purpose as we can make it. And on top of that, certain DSLs or more domain-specific modeling syntax can be created. This will allow us to share the infrastructure code on the statistical library and also the inference algorithms. Second thing is during the pandemic, we actually worked together with some infectious disease modelers, and to understand their needs is actually very, very helpful. Something we learned is that the model can quickly grow fairly complicated, and creating syntax or abstraction tools to manage the complexity, both the modeling complexity, the communication complexity, and also the inference complexity is very, very important. This is often actually more than what the models we typically see in machine learning. In machine learning, we see very big models, but structure is relatively simple. But in infectious disease models, the model size in terms of the dimensionality might not be so big, but the structure can quickly grow very complicated. Also, it might involve data from multiple sources and different fidelity for these different data sources. So the model has to be able, or the probabilistic programming language has to be able to cope with that. Another aspect is the workflow for probabilistic programming language is very important. It's not just providing a black box inference algorithm to the user. It's also about creating tools for the user to work with the model, to debug the model, to debug the inference algorithm. Complicated models often will break your general inference engine. So providing tools to debug your inference algorithm and also to allow the user to modify the model accordingly to fix the inference issue is very, very important.
Thanks very much.
Yeah, I think you make it very difficult for me to say something. But so I think one of the things is that most of you here are mathematicians, so I was very lucky, and I think you did the right thing already to think a little bit more multidisciplinary and see what other disciplines are actually doing. So you could see that I presented one or two models, and they're actually from a software that's used in operations research. And we were talking about, well, the seminar is about preparedness as well. And preparedness means, do we have the operational capabilities to serve the people once the pandemic is here? And by just looking at the SIR model in isolation, you will not find that out. So I think it's good to engage with the other disciplines, and then you can still build the same kind of models, but you get input from other sides as well.
Thanks.
So speaking as a programming languages person, we often find ourselves as people with a hammer looking for a nail. So we know how to write programming languages in a principled way, we know the abstractions, but I suppose really to get that engagement, it's good to know where to find the domain-specific knowledge, you know, where the resources are to learn about, more complex epidemic modeling than just a simple SIR model and how it's done in practice. So finding those inroads into communities that are outside of our own, I think for me would be very useful.
Yeah. Okay, thanks. Yeah, so there are some ideas there around kind of getting the interface right, making people, or designing interfaces that people feel comfortable with within their domain. Ideas around managing complexity, that's one that's kind of very close to my heart really, finding that sort of level of abstraction. And then this kind of tendency for us to really sort of, we sometimes end up in a box with one particular very narrow class of models, an SIR model or an SEIR model, and it's difficult to actually, as an epidemiologist, sometimes to step away and think about models in a much more sort of general context. So, are there any comments from the floor that you'd like to kind of come back on anything or add to the discussion on this? Emma walks in the room. No, that's fine.
I have a question.
Oh, yeah.
Well, which of the disciplines, you mentioned operations research, but which of the disciplines have done this more successfully than us in infectious diseases?
I think there was, is it BEAST for phylogenetics? I think is very, very popular and widely used, certainly.
But with BEAST, I mean, BEAST you can put in a lot of different components in, but would BEAST really be a language? Certainly a tool.
Yeah.
I mean, STAN is a good example, like it's used in epidemiology, but also social sciences and political sciences, mostly because of Andrew Gellman, who's very good at.
So someone mentioned ANSYS in their talk. Was it you, Guillaume?
Oh, yeah, but it's for synchronous languages.
Yeah, okay.
It's an entirely different community, but...
Yeah, sure. But, I mean, it's a piece of software that serves that community extremely well.
Yeah.
And tell us a little bit about it. Is it a commercial piece of software or is it community supported? Or?
Yes, it's a commercial piece of software, and it originated in a transfer from academia. So there was a bunch of researchers working on synchronous languages, and then this was taken by an industrial team who rebuilt their own compiler and sold it to Airbus, basically.
Yeah. Right.
This is one of the great success of French academia.
Very good. Yeah. Okay. My second question, really, I asked, well, Simon Frost asked this actually on our kind of program Slack channel yesterday, just making the point that there are a load of domain-specific languages or probabilistic programming languages. Why have we ended up with kind of so many of these things and none of them quite seem fit for purpose? Anybody got any comments?
There are so many domain-specific languages because there are a lot of domains for a start.
Okay. Yeah.
I think if you are going to specialize a language design to a particular domain, then you get to a point where maybe you want to go slightly outside of what you've got, and you've over-specialized the language design, so you need to make a new one.
Yeah.
So it's about having that. It's always a tension when you do a domain-specific language, just how specific you want to make it. Obviously, the more specific you can make it, the more precise your analyses can be, the better optimizations you can do, that sort of thing. But you don't want it to be useless. So that's always a tension there.
Yeah, okay. Justin?
I mean, I think part of the reason, like quite simply for epidemic modeling, there's so many domain-specific languages is nobody's hit the sweet spot.
Yeah.
Right? Like they may have hit the sweet spot for their team and stuff like that. And I think a lot of time, or at least when I've gone and looked at others, it's actually that they've tried to obscure too much of the complexity. It's not that they've overexposed the complexity, that they've tried to make it obscure too much, and it's quickly becomes easier for me to write. I mean, it's just not that hard to write a set of differential equations
exactly.
and throw it to a solver. Write effectively a different, a stochastic difference function, a stochastic difference. So you really have to have some value add and also make the adding the complexity a lot, both a lot easier, but still understandable. Because I also think, like all of us who do infectious disease dynamics epidemiology, like we're all sort of scientists in a way that we're very uncomfortable using something that's like capturing part of the scientific process that we supposedly understand, the epidemic process, that isn't exposed to us. And I think like if you, yeah, so I just, there's some sweet spot there that I just don't think anyone has hit. Personally.
Sure, Guillaume.
Yeah, I think part of it is that people love to build their own languages, like in any domain, and it's particularly true for probabilistic programming because it's really mostly in research communities, and people tend to build their language to highlight some of the difficulties or highlight some possibilities or other possibilities, and build prototype for one paper or the other. And there have been few efforts in building kind of universal probabilistic languages that can be used in any community. That's not entirely true. Like we've seen a great talk about Turing and there is Stan and so on. And these are very good efforts. And maybe what we can do is use these existing efforts and try to build on top of them instead of building from scratch a very nice solution with a very nice technical contribution for one research paper.
Yeah, I think that's a very good point. Sure.
I think nobody's happy, otherwise we wouldn't build constantly new things. So we think that all the existing libraries or languages are flawed somehow, and we can do it better.
Yeah.
So we have to start new. The other thing, maybe at least in computer science, is like that we are forced to publish. And we can't publish something if we don't have anything to offer. So we all brand our thing as a new breakthrough, so we get published in high-ranking journals. And I believe that's the wrong policy, that we are forced to do this. And the last bit, maybe, I don't know if there's a body, like a special interest group or something, where everyone, like we do here, everyone in more depth knows what the other languages are doing. So maybe building something like that might be useful if it doesn't exist.
Sure. Yeah. Okay. So a community of practice, in other words.
Yeah.
Yeah. Okay. Yeah. Oh.
I think one technical aspect is we don't have a clear decoupling between modeling syntax and inference algorithms. So a lot of the PBLs or the DSLs are designed for specific inference engines.
Yes.
And if you want to change that, you have to create a new one. And we kind of have to work out what's the intermediate layer between inference side and the modeling side. It's a hard problem.
Okay.
Yeah.
Thanks. Okay. So question now for the floor maybe. So thinking about epidemic models aside, let's think about more kind of generic models, hierarchical linear models and that kind of thing. So I'm sure some of you might use STAN or BRMS in R or OpenBugs or PyMC3 or Turing JL. What is it that might make you use a framework like that rather than coding your own MCMC up from scratch? And why don't we apply the same kind of mentality to infectious disease modeling?
I think for me, one of the big things is performance. I know I'm not coming from the strongest of computer science backgrounds, so when I conceptualize one of these inference problems, my mind doesn't immediately go to use every core, every thread, every bit of resource, like hardware resource that I have available to me. It goes towards the correctness of the algorithm. Am I actually targeting the right space? So I would want a tool that takes care of the stuff that I'm not good at, while letting me focus on the stuff that I'm where I'm comfortable with, and then going from there.
Sure. Ben?
Yeah, I guess for me, part of the reason for using bespoke code is that often with the complex models that we use, we have ideas that certain algorithms might perform better on certain parameters in your models. Hamiltonian might work really well for infection rate or something, but then if you've got some discrete parameter, then that approach isn't going to work. So by designing your own, you have the ability to very carefully tune the algorithm or
So it gives you a bit more
algorithms
flexibility around, yeah.
Whereas if you're using PPL, you've got to.
Sure. Yeah. Danny.
Because I think there is not a standard so infectious disease model.
Yeah.
People have got different ways of using the data, different specification of the model, and therefore that is difficult to encode into something that could be good for everyone. I mean, including the fact that you might have some algorithm that might be more appropriate for some situation. It's the heterogeneity of the type of model.
Sure.
That I think induces people to write their own code.
Yeah, I'd probably agree. It feels like some thought around, again, as you guys have been saying, like the right level of abstraction in the mathematics as well as in the code. Justin?
I think Glenn had something to say first, but then I have something.
Oh, sorry.
Yeah. So I was just going to second what Ben said. The inference algorithm is very unlikely to work out of the box for a new problem. So you're always sort of adapting them. And then the other thing I think is probably what Danny was saying, which is that I kind of thought epidemic modelling is quite an open-ended sort of discipline. There's not like a set of standard tools like say Beast, where and even in that scenario, there's other tools that people sort of seem to be using more now that are outside the Beast environment. And so I sort of had a nasty question for the panel, which was for everyone apart from Justin, when he was presenting his kind of setup, did you think, okay, my language, what I'm doing could implement what he wanted? I suppose is the question.
Why not Justin?
Because I was the one who said what I wanted.
Yeah.
Oh, I see. So
And you already answered that it doesn't do everything. So it's a totally unfair question, but I thought maybe it's interesting to hear people's thoughts.
If we all look at each other, we all thought we can do better.
Probably true.
I think it was quite interesting to see how far you could get with YAML, right? Because that really was just writing down data. And it was very interesting to see, but I imagine that you ran into problems where you were just like, I want to compose things.
Right. Which is why the whole second.
Which is why the whole second. So I mean, that as soon as I saw the YAML, I thought, right, that'll get you so far. How far along are you with the second piece of it?
Not particularly. I've done like 3 or 4 toy problems.
Yeah.
Yeah.
Yeah, it looked like a nice programming model, actually. Did it start to solve the compositionality problems that you had with YAML, the YAML-based?
Oh yeah, definitely.
Yeah.
And with like just the general approaching things in compartmental. I haven't used it for real work yet.
Right.
We need another pandemic then.
You don't want me crying here on stage. But just to say, like, one thing that hadn't come up and why people haven't used stuff is, I think, like, this combination of crappy documentation and information and options overload.
Yeah.
Right? Like, I just think back, I remember very distinctly that, this is back in my software engineering days, an example, that IBM had a project, WebSphere, that you could basically set up any type of like web portal service you wanted in like 4 lines of configuration. But it would take you 4 days of going through WebSphere documentation to find the right 4 lines of configuration. And I know very few people who can code at all that would rather spend 4 days looking for 4 lines of config than just try to code it themselves from scratch and know they were going to get a good enough solution. And I think we're in a same, at least I feel like, with maybe the exception of Stan and Bugs a little bit, like Bugs and Jags a little bit, like I feel like when it comes to me thinking about adopting a new probabilistic programming language or domain-specific language, like I'm in somewhat of the same place. There's so many options. They're, in general, I don't say they're very poorly documented, but they're certainly not documented in such a way I can, in 20 minutes, figure out if they meet all my needs, and or even most of my needs. And I know I can write it, I know I can write an MCMC sampler that'll work at some time scale, right? And, I'd rather spend my 5 hours doing that than like looking at obscure documentation for 5 different probabilistic programming languages.
I think you hit a very nice topic. Documentation is a problem not only for programming languages, also for models.
Mm-hmm.
And in the social simulation community, we have something called the ODD standard. So whenever you submit a model, or in your case a programming language, there is a protocol that you have to submit as well that describes the reasons why you developed it, the design in a very standard way, what it can do, how it runs, and that can be up to 20 pages, but it's all sections with headings. And you can't publish without. And I think maybe a standard like that would help for the models as well as for the programming languages.
So just to kind of say, in the programming languages community, I think it was pretty much Wild West before about 2015. And in 2015, the main conferences also had a separate review process for the actual software artifacts that went along with the papers. And in order to go and get that kind of accreditation certification, you had to show that it, a reproducible build. So it'd have to be on a virtual machine, and it would have to have a certain amount of documentation, and it would also need to support the claims that were in the paper. So certainly from a software reproducibility perspective in the programming languages community, we've got better at that. But even it's starkly different world to how it was early 2015, when people would just link to the software on their old 2 institutions ago personal homepage, and it wouldn't exist. And even if it did, you would never be able to build it.
That's true. Yeah, I think that's true. Just I don't want to put you on the spot. Maybe Paul and Danny. What's the UK HSA line on kind of model documentation? I sort of had in the back of my mind that there are a set of guidelines that modelers are supposed to adhere to, or at least read.
There are. So, I mean, this is something that's probably come along since the... Oh, sorry, so this is something that's come along since the pandemic. There's been and formation of the UK, to say, from PhD. There's been a greater focus on quality assurance.
Okay.
And making sure that models are properly documented and there's sufficient peer review around their use.
Yeah.
There's the cross-government Aquabook, which is the guidelines for developing software, which I don't think were being used particularly extensively in PhD, but it's great to focus on there.
Yeah, it's interesting. Yeah, okay. Emma.
Well, I was part of a paper that did a study of reproducibility of a random sample of, it was in Academics, that been published, of models published during the COVID era, not all on COVID, but most of it. And yeah, the reproducibility was totally shocking. I'm very happy to give a 5-minute synopsis sometime later in the week if people are interested.
Yeah, that'd be really interesting. Yeah, thanks. Okay.
Reproducibility is a real issue, because I know from my code that I used during the pandemic, it's all it's on Git, it's all versioned, all updated. But I mean, from someone starting from scratch, it's never going to be reproducible by anyone other than me or someone working closer to me.
Yeah, because the documentation about how to run the model, what data to align with it.
Because lots of the development was done in pandemic,
Exactly.
so the development was done, but the documentation is always several versions behind, if that.
Can I contradict myself just slightly?
You can.
Or not contradict, but maybe give a ray of hope.
It's an open floor.
Well, one thing, like on the documentation, not on this part of the documentation, I think, but on the documentation of the programming languages adopted, I do think that is one, you know, as much as I think the promise of like large language models is oversold in a lot of different ways, it does substantially decrease the barrier to learning a new language. Learning a new programming language, I've encountered multiple times, taken advantage of multiple times myself. I think as we get that more embedded in our learning workflow, maybe people will embrace, you know, maybe there will be broader embracing of different programming languages, and maybe one will rise to the top. You know?
Sure. Yeah. Carl?
I'm going to throw a big asterisk against that. So I was dealing with like new trainees who were using that as ways to learn language, and that was super danger zone. Totally agree that like if you already know what you're doing, picking up a new language or a new framework, the like Copilot or any of those LLMs, super helpful. You could talk to it. But for the new trainees, they were setting themselves up for failure by using LLMs. So,
Interesting.
Yes, I've had the same experience, and I completely agree.
Interesting, yeah. Okay. All right, so moving on, we're doing quite well actually. I've sort of roughly allocated about 15 minutes of questions, so we're doing quite well. Question about funding. So certainly been my experience in the UK setting that actually persuading funders to fund bits of software that are intended for other scientists to use, so a kind of a translational tool, is actually quite hard. Does anybody have any thoughts about how we can kind of present ourselves to UKRI, to the European Research Council, to funders in the States, the NIH, for example, in a way that would attract a little bit more funding to actually turn some of these kind of fledgling ideas into kind of more kind of mature projects?
Yeah, I think this is changing a little bit. Like Simon mentioned, the fact that at least in the programming language community, we have this artifact evaluation committee in big conferences. So people tend to value more and more softwares. And we've seen even in a research institution, people that are doing really software-oriented stuff. Like I'm thinking about scikit-learn, for instance, which is a great library, but it's nothing really new. It's just a really nice packaging, and it's a lot of very impressive work that is not typically valued as a research work, and yet it gained some very nice recognition recently. So I'm really hoping that it's starting to change.
Yeah. I think you put your finger on the problem there, that often creating either a DSL or a software package is not kind of new science in some sense, but it's making the existing science more accessible to people who wish to use it as a tool, I guess.
Yeah, but it's still very difficult to convince people when you're applying for a research grant. That,
exactly.
I'm going to do a lot of software development.
True. Yeah.
In terms of actually convincing people to give you money, yes, that's difficult. There are funding routes for it. So certainly at Glasgow, we have something known as an impact acceleration account, and the idea for that is if you've got an early prototype and it's shown promise and you've basically done the research and you need to make it a bit more robust, then you can apply for short, 6-month pots of institutional money to go and actually work around that, doing just engineering work. So that's a good funding route if you can do that, but you need to have had the funding to get you to a point such that an application to that pot of money is actually worthwhile. I just want to touch on the first-class object bits, if I can. So in terms of actually saying to a research funder that you have made software, at least nowadays with these artifact evaluation processes, but also kind of repositories such as Figshare and Zenodo, you do actually get a DOI for your software. So it is there as a research output in its own right that is separate to the paper, which is good in itself. And I know that, ways that UK research funders collect information, such as as ResearchFish, for example, you can put software in there. as an output that is separate to your papers. And yeah, there was one other thing I was going to say, but I've forgotten. It'll come back to me.
Does anybody else have any thoughts?
I mean, we just got a ton of money dumped on us.
Right.
Exactly.
Good adjusting.
For, you know, operational support of public health, particular state, territorial, local, and tribal epidemiologists, right? And part of that, I think, the types of software we're talking about here is maybe a little too abstract to pass off to those folks, but having tools, you know, but in that, the software tools are first-class objects, right? Tools that we can pass off that they could actually use, or levels actually use, are first-class objects. Also, our operational work and our operational support and analysis is key, and I think in that context, I have no problem spending our money supporting like our internal development of some of this type of stuff, because I know, or I strongly believe, in a crisis and even in between, it's going to make us much more effective and nimble, and it's fulfilling. So having that another way of saying is if we have sustained funding for operations and improving operations, having good software, nobody in this day and age would disagree with the idea that having good software is a key foundation of strong operations.
Yes.
And so in that sense, we have gotten money in the United States in the infectious disease community to support some of this that a lot of people are spending in software. I do think but there's also another place that needs to be first-class object, and that's in promotion committees. And I'm not sure in epidemiology that it is on promotion committees yet, right? Like just in biomedical sciences, right? Like the expectation for the amount of publications you make in a year is like, you know, like on the order of 10 or more, right? And, you know, that's just, if you're developing software and writing papers about it, at least when I was in IBM, like, which branch of this industry, like 1 every 2 years, or, you know, or a couple a year was like more the standard.
But with a really robust piece of software.
With a really robust piece of software under it. So I think just getting credit for those, so they need to also think about first-class software, because nobody's going to do anything that just keeps them being, you know, what would it be here, a lecturer the rest of their life.
Yeah, maybe just some blue sky thinking, but in the UK we have knowledge transfer partnerships. So that might be a resource where the university pays half and the employer pays half. Unfortunately, the IP goes to the employer. But for software development, for learning, that might be a way of getting some funding.
Yeah, short-term KCPs.
Yeah, and more generally, like having a partnership with a private company can be a good thing. For instance, you mentioned ANSYS, and ANSYS is still giving some money via contract to academics.
Okay.
And they continue to work on this together.
Sure.
And in the context of probabilistic programming, I think STAN is backed by multiple actors, including the Simons Foundations and things like that. And PyMC, they have a startup that's
absolutely.
You should work on that, and you can convince them to give you some money.
I wonder what the Turing JL funding model is. Is this something that you apply for grants in a kind of stepwise fashion?
Yes, but for the first few years we didn't have any funding.
Okay.
I think GitHub is a good thing. Open sourcing is a good thing.
Yeah.
Establishing some public metrics about the software in terms of people who studied, people who cited, people who we have professors teaching Bayesian stats at other universities. And these things does help for us to get funding at a later stage.
Yeah.
Another thing is to connect with users, talk to a few high-impact users, get them involved in the software development, maybe also the grant proposal writing process.
Yeah.
Right. It's a lot of stochasticity as well.
Sure. Yeah. Okay. Yeah. It's always the random effect. Yeah. Definitely. So I guess what we're sort of hearing here is kind of co-creation with your target users is kind of really important, and actually getting that voice from the target user to say, hey, there's a demand here. These guys think they can build it. Let's work together. And
that seems to be the shared secret between Stan and Turing idea. I think Stan was also doing something similar. They talked with users in the pharmaceutical industry.
Okay. Yeah. Interesting. Yeah. I mean, there's a question there for us as infectious disease modelers of who are commercial, who in the commercial sector, who in the business sector would be interested in languages like this, and maybe we have to actually think a little bit beyond kind of one-off pandemics every 10 years to actually think about actually where can state transition models actually work in business and finance and kind of thing, get it funded that way. Okay, Jess.
Well, it seems like in academia as well there seems to be no good funding model for maintenance of software once you get a project funded as well. So I feel like you hope to have an engaged user base that's going to help progress the software after the project and bug fix and things like that. And realistically, that shouldn't be sufficient. And that seems to be a problem.
Yeah. So that kind of brings up questions about funding models, and maybe a little bit like what I think you were suggesting, Justin, is that alongside software, actually you've got a whole team of rather capable epidemiologists and computer science who can kind of add value to that software by providing consultancy services. And so the software that you use in-house, you have an incentive to then continue to develop and maintain alongside that advice.
I mean, this is like also getting a little bit to the operations. Like, we have problems that, things that would be considered, high-paying, co-equal positions with the technical folks around project management and quality control and stuff like that in industry, at least in my corner of academia, there's no equivalent positions at the university for this.
Yeah.
Like, we cannot hire people with those still skill sets even with the academic do-good discount that, at competitive salaries, right? Like, and that could be a 50% discount. We still can't match 50% of what they get in industry.
Sure.
And that's, nobody's going to come work for you.
Okay.
I think Carl has a
Oh, sorry, Carl. Yeah.
Quick question to see what people know about it. So you mentioned that Stan has like a 501c, whatever charity behind it. But how could we, let's say I'm doing a new project. I know I want to use Stan, but I know that it's for this is the future where it's not maintained or something like that. It needs to be upgraded to a certain version. How do I put in a grant that says, I want to pay the Stan developers, I want to pay that foundation to make this thing happen, right? Stan is only set up as a charity of, you can give us money, and then we'll do whatever we want with it. But like, how do I go to, as an organization, and I'm picking on Stan here probably unfairly, but it's something we ought to be asking ourselves about, setting up tools that we want other people to use. We have to make it possible for them to pay us to fix the things that they want, right? Even if we aren't in a profit-making business, if we want to respond to users, right? And we have to figure out how to convince funders to not balk at that, and we have to convince our institutional, like project management, accounting, finance folks, not to balk at, oh hey, we're gonna pay the people who work on Stan this chunk of money to go solve this particular problem for us. and not make it a giant pain in the butt. So that seems like there's an interesting financing whatever question that I would love to hear people's thoughts on whether or not they have seen a model that succeeds on that front in academia. Clearly that version works out in business all the time, but we're all averse to making money. So
I don't know whether this is a Glasgow thing. Oh, sorry. I don't know whether this is a Glasgow thing, but I spoke to somebody who did have one of these impact acceleration accounts. Yeah. And I think all they wanted to do was to use this money to go and pay somebody to write a report. And apparently it was so agonizing to work with the university's legal department on this that it was not something that they would ever do again. So I think institutional bureaucracy can really, really get in the way. So that part very much chimed with what I heard from some of my colleagues.
Yeah, I think it's a completely different idea, new idea, but we could set up a culture of crowdfunding, and it might be that in a couple of years' time, in this way, projects can be kept alive, and people or universities are supposed to support tools depending on their use, something like that. But I think crowdfunding, I never heard in an academic context about this, and you can see that in projects, people get a lot of money together. So that might be one way of maintaining software, because it's very big.
The fact that you haven't heard it in the academic environment, maybe there is a reason.
Yes, but we never tried. That's the point. I haven't heard of it. I think.
I mean, two comments, and one just directly in that. Like, I had at one point a crowdfunding group contact me about if I was interested in having a university research crowdfunded, and I was like, oh sure. How much do you think we could, fund? And they were like, $6,000-7,000. That, like, the admin overhead, is not. That's just there's no world where that's worth the headache. For like, my budgets are 100 times that. Yeah. Right. And but the other thing I think is another way to think, like, I mean, I know there's a lot of ways that, Linux is contributed to by industry, but one of the ways Linux is contributed to by industry is that they hire developers to work on Linux because it's valuable to them to have a stable and effective, operating system they can use. And like, so even if it's hard for us to give money to like some group, the group that can stand, right? Like, it may not be impossible for us if we have a larger project to hire somebody for that some part of their effort is to helping with whatever open source, Stan or whatever source open source software project that they have, or if we have a big enough pot of money, like subcontracting to, because a lot of people who work at Stan are like mostly in academic institutions, right? And they can take subcontracts.
Yeah, I think I wanted to say basically the same thing, is that the model of Stan is open sourcing everything, so you can hire someone as part of your research group and ask him to or her to work on the project, but then you have to fight the consortium that is leading the development effort. You have to convince people that they actually need to merge whatever you are doing in the main project, and this can be super hard. So there is pros and cons. Then again, you can still fork the project and continue working on your own branch, but there is a problem of adoption. And just on the crowdsourcing thing, I think this is already possible on GitHub. You can sponsor random projects if people set up their account correctly, and it's relatively easy to do. Then again, you have to convince your institution that they need to invest $10,000 on a given project, and that may be difficult.
True. Or to let you take the money. I don't know. I can't imagine what it would take for me to take $10,000 from random sources in GitHub.
Okay, last question, last 10 minutes or so. This one's about performance, and I'm particularly thinking here about sustainable compute. So we've all heard recently Google's announcement that they're using 50% more energy than they were 5 years ago because of large language models, et cetera, in kind of Bayesian inference, in simulation, micro-simulation, agent-based models, et cetera. Complexity seems to be growing, so the computational demand from our software is increasing. So what do we need to do to ensure that, I sort of put domain-specific PPLs here, but software in general, what do we need to do to make sure that our software is making the best use of available hardware in such a way that we minimize the energy need to do our computation? We're not wasting cycles.
So one thing, I read a story, I think it was on Twitter back in the day, but it was somebody who was a research software engineer themselves, and they just got chatting to somebody in physics, I think. And, you know, the person in physics had written a model which worked, but I think it had like a 4 or 5 nested loop. And, you know, this RSC went and chatted to this person and managed to go and take something which took hours, maybe days to run, to do it very, very quickly. So I think sustainable funding of research software engineers is definitely a good thing. And, you know, forums like, you know, the RSE conference, those are really, really good initiatives. I suppose kind of more technically, if you do have the right level of a domain-specific language, then the optimization space becomes a lot smaller because you can do much more targeted optimizations. So it's an inherent advantage of having a correctly designed DSL such that you can optimize things better.
Yeah, okay, so it's kind of compiler designing.
Yeah.
Yeah, okay, yeah.
Yeah, I would say one thing that we could do is sharing more codes, and to go back to what we discussed previously, do not write your own NCMC sampler. Like
Yes.
You could do something that is very optimized, and or work on something that is already fairly optimized to make it better and usable by other people. That would probably be an answer. Yeah. And so invest more in software development, because I feel like if we are all focusing on research projects, we will want to try the new shiny thing and plug LLMs to MCMC samplers, for instance, just to see how it works, and maybe we will get like 5% more accuracy, and we'll say we cannot go back from that, and we need this energy. So yeah. Maybe we need to take a step back and invest in more robust software that are heavily optimized, and so it's very difficult to do better just by coding an afternoon or a weekend.
I think maybe make it easier to test and validate, and maybe instill in the people making models more of a understanding of how to test and validate components of models without doing the whole thing.
Yeah. Because
I mean, even myself, who in theory knows that stuff, and maybe it's very much in theory, you run a massive simulation and you realized you made an error. Only after you've run the massive simulation, it's just gonna be you're never gonna completely get rid of.
Yeah,
but
sure.
That's a huge impact of resources and money and environmental impact that was completely avoidable by simply having been able to test, having had your software built in a way you could have tested the critical components that you added in independently on your laptop that uses basically zero power.
So it feels like we're going back to Guillaume's suggestion, do not write your own MCMC.
Right, do not write your own MCMC, but also try to write your, kind of the types of things I was showing, if you have a nice object-oriented framework, right, I can test my rule without testing it as part of the whole model. Whereas if I have to unroll the whole model to test this possible modification, then I have to have the capability to run, run the whole model.
Yeah. Danny?
You know, this conversation made me think that I forgot something earlier. You know, your question about why people don't use, why people keep maybe writing their own MCMs, because some of this sort of software are not transparent enough.
Okay.
There is, you never know what is magically producing something, and whether there are tuning parameters or things that can be tuned to get something quicker, faster, better, or whatever. It's never possible to have all those choices that you have when you write your own code, which is a little bit shooting yourself in the foot. But at the same time, if the software was a little bit more transparent, people would be more trustful.
Sure.
Yeah.
Yeah. That's true. Sure.
Yeah. In my discipline, we follow the Pareto rule. I don't know if you know the Pareto rule. It says 20% of effort gives you 80% of output, of result. And then for the rest, you spend a lot of money and time to actually get the missing 20%. So maybe we don't have to try to make the world perfect to find the optimum, but we are happy with something below that. And we would save a lot of computing time. Don't know if it works in your discipline, or if you always have to have the perfect model to make a prediction. Maybe not.
Yeah, there's definitely a tension there between, trying to optimize things to the last. It comes back to the publishing thing, kind of that sort of 5% increase gets you a paper, but you might be using twice the energy,
I just wanted to mention something else. Sorry.
Yeah, sure.
It's in the programming language community, we have all these shiny compilers that start with some static analysis that could be super useful. And designing new static analysis in the context of probabilistic programming, or say epidemiology model or things like that, is an open problem that is, I think, very interesting.
Yeah.
And it will help you, like, instead of running your simulation and have a runtime error, you can statically detect the most obvious mistakes, at least, and that can be super useful. And again, this is something that takes a lot of time and effort, so this is not something you can easily add to your handwritten MCMC samplers.
Yeah, that's very true. Okay, all right. Well, we're just about out of time for the day. We said we'd end at 4:30. So I'd like to just end up by thanking our 5 panelists, and indeed thanking everybody who's spoken today, and thanking you guys for coming along. I think this day's actually added quite a lot to our discussions for this 4-week program. They do 6-month ones as well. And I think actually that's given us quite a lot of food for thought for how we actually push some of this work forward, and how we think about kind of making our subjects a bit more resilient if indeed we get another, if and when we get another pandemic in the future. So do hang around a little bit. There's plenty of time. I'd probably be walking into town for a refreshment if anybody wants to follow on. We were going to try and get to the Raspberry Pi shop, but unfortunately it closes at 5 o'clock, so we might be kind of pushing it. But maybe next time. So thanks very much to all our panelists. Thanks to the audience.